This question is question 17 from the GATE 2020 EC paper, and we are given the following circuit with a 230 volt RMS input and asked to find what the magnitude of the steady state output V0 is. The diodes are assumed to be ideal. Underneath the question you will find the title of the NPTEL course or video relevant to this topic. So in this question we are given that all the components are ideal. What that basically means, since in this circuit we have only two components, a capacitor and a diode, is that the capacitor and the diode are ideal versions, which is to say that the capacitor simply follows the following IV relationship, right? It has, if it's say it has a capacitance C, it follows I equal to C dV by dt with the following directions and polarities. And the diode, if it has Vd as plus minus as so, then for Vd greater than 0, the diode can be replaced by a short circuit, and for Vd less than 0, the diode can be replaced by an open circuit, that is during forward bias or reverse bias. You could also consider it as the diode current flowing that way. So the idea is that ID equal to 0 during reverse bias and ID not equal to 0 only during forward bias, right? So this is what it means to say that the components are ideal. And secondarily, in the question we are given that the input is a sinusoid, right? Input voltage is sinusoidal and has 230 VRMS, 230 volt RMS voltage, which of course means that if we say that the input is a sinusoid, right, it's like that, and the amplitude is 230 root 2. So now let us analyze what will happen first in the negative half of the inputs. So in the negative half of the input cycle, what happens is that the input voltage with polarity V as such is that V is now rising to 230 root 2 volts. So this will be V heading to a magnitude of 230 root 2, and of course since the polarity of V is opposite to the input polarity, actually the input voltage is falling to minus 230 root 2 volts. So during this you can clearly see that V is trying to impress a current in that direction. Current always flows from the positive to the negative of the input polarity, and now as V is trying to impress a current in the direction of the diode is forward biased, so this can be replaced by a open circuit, and the capacitor will now charge up, because for a capacitor to have positive current like that, remember if the current is like that, if the current is like this, then the voltage polarity is like that. So the voltage for the capacitor Vc1 is actually now increasing because it has positive current, right? For the following voltage polarity, the current is into the plus, and so the capacitor is C dV by dt is increasing now. Yeah, so the idea is that C dV by dt, since I is positive and I equal to C dV by dt, C dV by dt is greater than 0, so that means C is greater than 0, the dV by dt is greater than 0, so the voltage is rising. So now the capacitor voltage is rising, and how long in this polarity the capacitor voltage is rising. So it will rise for as long as the input voltage is rising, right? Because essentially, since this is a short, what will happen is that this V will just come and apply itself across the capacitor, right? So as long as the input voltage is rising, the current into the capacitor is positive, and so this current is also positive, and that diode is turned on. So now what will happen is, as soon as the input voltage hits the point from which it no longer is rising, right? So V is like that, and V is no longer rising. V is dV by dt is now 0, right? So if now input voltage starts falling, and we still were to assume that the diode is conducting, that is, the diode is in forward bias, right? So V is like this, and it's now decreasing. That means current is flowing like that. The positive direction of current is like that. And since we know that this diode is turned on because V is like that, so that really can't, so the V comes like that, and so therefore that diode is turned on. This current has only this path to go, but that would mean that it is flowing in the direction like that through the diode, and that's not possible because diode only has a positive direction of current like that. It doesn't have current flowing like that, so that's not possible. So now what you will get is that the V, so this V is falling, but the idea is it cannot any longer appear across this capacitor, which is to say that this diode no longer can be in forward bias. This diode opens. So this will take its value 230 root 2, and since now this diode is open, and also since this diode is open, this voltage really has nowhere to charge any capacitor through. And now once the voltage V becomes positive, right, once it crosses this mark, right, once it crosses this mark and goes above it, the polarity of the input voltage now flips and starts rising towards the starts rising towards plus 230 root 2. You can see that this and this will add up over here. The voltage at this point with respect to this point will be, the voltage at this point will be 230 root 2 plus V, right? And V is now rising. V is rising to 230 root 2. So since that is 230 root 2 and it's coming on the diode P terminal, this diode will allow it to conduct, and it will appear across the capacitor. Since the diode in conduction is in forward bias, it can be replaced by a short circuit. So essentially 230 root 2 plus V will appear across here, and that will last as long as the input voltage is rising. And since this voltage is rising, it means that this capacitor has positive current like that, right, into the plus of the capacitor, and the current is has magnitude greater than 0. It has positive, this is the positive direction of current, and so current flowing into the capacitor voltage is rising. And how much will it rise to? It will rise for as long as this current will flow, and the current will flow, so as long as the current is flowing, the voltage is rising, and it will rise till this point, right, till the point where the input voltage V reaches plus 230 root 2, right? So when V reaches plus 230 root 2, the capacitor voltage will become 230 root 2 plus V, which is now 230 root 2, which is 230 into 2 root 2, right, which is what is given here is 650.54 volts, right? So the capacitor will reach 230 root 2, and then after that, once V starts falling, right? After that, once V starts falling during the during the second half of the positive half cycle, you can no longer take it that the 230 root 2 plus V is on the capacitor. Why? Because if 230 root 2 plus V is on the capacitor and this whole thing is falling, I'm saying if it's like that and it's falling, that means current will be flowing out of the capacitor, right? It will be flowing out of the capacitor, and it has nowhere to flow except through this diode back. And as you know, if you try to force, you can't have current flowing through the diode in that direction, so this will open, right? So that means 230 root 2 plus the peak value of V, which is 230 root 2, will stay on that capacitor. So during the steady state, the magnitude of the steady state output will be 640.54, and as soon as the input crosses the negative half cycle, you will have the same thing repeating from this direction, except now that the capacitor will be fully charged and ready, and but the same magnitude of charging like that and then discharging into that will happen. So the steady state value will be 650.54 volts. .54 volts.